Hi, so this is going to be your second question to neutralization calculation. Let's look at the question. We have 34.62 mLs of 0.1510 molar sodium hydroxide was needed to neutralize 50 mLs of a sulfuric acid solution. What is the concentration of the original sulfuric acid solution? Alright, so there's a lot of numbers, but all I know is that it's a neutralization, so I'm going to write my reaction down to sulfuric acid. And then I need to determine what my products are. So I know because it's a neutralization reaction, I have water, and then my cations and anions are going to combine. So this is going to have my aqueous in the solution. This is my water, which neutralizes everything. Let's look at the numbers. Sodium hydroxide I have 0.10, excuse me. A molarity, and this is in 34.62 mLs, and then this is going to be a 50.0 mLs of sulfuric acid. So if we were to look at this in a picture form, what's happening is this. You have a glass or beaker of 50 mLs of sulfuric acid, and you put 34.62 mLs of 0.1510 molarity of sodium hydroxide, and when you put this amount in there, it actually neutralizes it. So the question is, well, if this amount is needed to neutralize this volume, what's the concentration of the sulfuric acid? And that's what the question is asking for. So then once you go back to this reaction, let's see if it's balanced, because I noticed that sulfuric acid actually has two H's instead of one. And I noticed that it's actually not balanced here. So let's balance this up. Let's see if I can maybe put a 2 here, and then 2 here, and then 2 here. So that's 2 sodiums, 2 sodiums, 2 sulfates. And then now I have 4, 5, 6 sodiums, oxygens I mean. Is that balanced? I don't think it's balanced just yet. 4, 5, 6 hydrogens are balanced. Are my oxygens balanced? 8, 9, 10, 8, 9, 10, 11. Oh, my oxygens are not balanced here. Oh, I get the reason. So if you look at this, my mistake was that I didn't balance this. It should be Na2SO4. Now let's try this again. 2 NAs, 2 NAs, sulfates, 1, 2, 3, 4. Okay, put 2 here, and I think we're good now. Alright, sometimes reading off the screen is really hard to see. Alright, so first thing, I keep saying first thing, it's actually not first thing anymore, it's probably like the fifth thing. Let's put some moles, get some moles from this. Sodium hydroxide, let's find the moles of this. I know my molarity equation is moles over liters, so I'm going to go 0.1510 m. Molarity is equal to moles over, I'm going to convert this to liters right away, so it's going to be 0.03462 liters. Again, I'm just shifting the decimal place here 3 times to get this number. Okay, and then calculate the moles. So let's punch it into the calculator. 0.1510 times 0.03462. My answer for moles is, the double check my answer here, is 5.23 times 10 to the negative 3, and this is the moles of NaOH that was needed to neutralize. So then now I'm going to look at my molar coefficients, and you're going to see this is a 2-to-1 ratio. I need to figure out the moles of sulfuric acid. So I can use this times division bar method. So I'm going to do 0.3, why am I saying 0.3? 5.23 times 10 to negative 3 moles of NaOH times division bar. And then remember, I'm trying to find the moles of sulfuric acid. So I need moles of sulfuric acid at the top. And I'm going to look at the molar ratios. It's a 2 and 1. So it's actually 1 moles of sulfuric acid will give me 2 moles of NaOH. Moles of NaOH will cancel, and you're actually going to get a smaller number because you're basically dividing by 2. Let me punch in my calculator. Divide by 2. My answer is 2.615 times 10 to the negative 3. And now this is the moles of sulfuric acid. So I have calculated, what I just did was, if I were to use this amount of moles of NaOH, how much of sulfuric acid is going to react and neutralize with it, and it's actually half as much, because sulfuric acid, again, when it dissociates, it will dissociate two H protons, which makes it a stronger acid, so you don't need as much. So let's use that number and calculate. Now, what am I calculating? I'm calculating the concentration. So I'm going to put my formula here. I have my moles of sulfuric acid. I have my volume. I don't have this. So I'm going to put these numbers in, 2.615 times 10 to the negative 3 moles, and I'm going to divide it by my volume. What's my volume for sulfuric acid again? 50 mLs. That means that it is actually, if I convert this to liters, 0.050 liters. And punch all this, divide this number, and finally, I'm going to get a final concentration of 0.0523 molar. So, what does this number mean, and does it make sense? Let's look at this. Keep this number in mind. Let's go back up here. We put this amount of concentration and this amount into sulfuric acid. Sulfuric acid actually has this 0.05 molar. I'm just going to round it to 0.05. You notice that 50 mLs is more than 34, but because sulfuric acid is a stronger acid, so this number makes sense. Just remember, if your number is like a massive number like 5.0, yeah, that doesn't make sense because this is such a stronger acid, right? Stronger concentration. So when you double check your answer, excuse me, double check it if it really qualitatively does it make sense. If it does, then your calculations are great. That's your neutralization reaction involving coefficients that's not one-to-one ratio. So hopefully try some practice question, and if you have any questions, ask me for help. See you later.